Hey, welcome back, and thank you for taking the time to just invest in making sure you understand things thoroughly. Hopefully, this will be helpful to you. We'll just jump into the next series of questions. We'll probably try to take about 4 of them on. So this problem number 5, I'm sorry, my copy is a little bit gray. My printer isn't the best, but it says we're going to use some completing the square to try to rewrite this in a slightly different way. So it has been a little bit since we addressed completing the square, but the way we handled that early on is we went ahead and we factored the value that was attached to that x squared in front. And again, everybody has their own way of dealing with this, but I tend to write it that way with that one sitting off to the side. I'm going to deal with that momentarily. Now, what I like to do is then I take that middle piece, which is sitting right here. We cut that value in half. Now, -3 cut in half is -3 halves. Not a big deal. But again, so if I take that value and I cut it in half, I get -3 halves. But remember, we cut that in half and we square that value. So if I took -3 halves and I square it, I would have a positive 9/4. Now, that really has created a problem because I can't just put a 9/4 there and call it good because I've changed my equation. And in reality, this is technically -27/4 right here. So what I need to do to keep this thing in balance, since I have a -27/4 here, I want to add 27/4 right there, because then if I took it away and I added it simultaneously from the same side, I have a zero sum, if you will. We have no change in the story. And so since this is -4/4, that's going to be 23/4. Now, the reason I like that version is that allows me to think about it more as a graph by transformation. So if we were thinking of g of x as being x squared, right, then f of x, which is this original function, would be g of, and let's look through what happened. The first thing I notice is that x got replaced by x minus 3 halves. I also notice this -3 is sitting on the outside, right? It's sitting in front of the x squared piece, and this 23/4 is out here. So if we think through that idea of the graph as it is related to the parent function, the first thing that I notice is a flip across the x-axis. See, it got flipped upside down. It got a vertical stretch factor of 3, right? So it got flipped and multiplied all those y values by 3. We went up 23/4. In other words, we added 23/4 to all the y values, and dead last, we moved to the right 3 halves, which is going to the right 3 halves. We could write it in a more formal way of calling it a horizontal translation of 3 halves to the right. But that gives me what I needed because my vertex, again, all of that movement would put my vertex at 3 halves, 23/4. Remember, insides are opposites, outsides stay the same. And of course, my axis of symmetry is at x equals 3 halves. Okay, so that's number 5. Okay, number 6, it's asking us to find the inverse. Now, there's one particular little nugget of this that really, really, really worries me because every year people really struggle on it and they just don't pay enough attention to this one piece. So please watch, I'll point to the star when I get to that value. So what I notice is this should be a parabola whose vertex is at 4, -30. So we're going to hold on to that for a moment. Please remember that. Now, we know that when we go ahead and do this work, we're going to swap x and y. And we're going to do whatever we can to now resolve that problem for y. So, of course, I'm going to move the 30 to the other side. I'm going to multiply both sides by 1/3. And here's where we get ourselves into a really significant step is I need to take the square root of both sides. And so when I took the square root of this side, I would get, usually I would get a plus or minus, but this is the important part. Ding, 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 ding. Is that you cannot take the inverse of a function that is not 1-to-1. It has to not only pass the vertical line test, it has to pass the horizontal line test, because we don't want to flip this thing and get this story where it will fail the vertical line test new. So remember, you swap X and Y, right? So it looks like this, but we need to eliminate the left part of the graph so we can eliminate the right part of the graph. So what I know is somehow I have to be in a position in the original graph where X is above 4, which means Y should be at least 4. My original range was that Y is greater than or equal to -30, so X should be greater than or equal to -30. And of course, the only thing left to do to finish this story is to move the 4 across, and so we're good. Now, let's put that there, and then a +4. I feel like I messed something up a little bit. There's a minus, oh, because I added 30 to both sides. Let's fix that. Let's make these all +30s. There we go. That makes sense with my domain and range. I accidentally added 30 to both sides incorrectly. So that's what's happening. Please remember that although this thing had a domain of all reals, I would not be able to take its inverse because it fails the horizontal line test. So it's critical that we remember that we make the function 1-to-1. So this portion passes both the vertical and the horizontal line test. Very, very important distinction. Okay, number 7. This is a big one. A big one. This is a hard one for a lot of people to do. So one of the things that I noticed was in my original question here. Again, sorry that this just doesn't feel like it's focusing very well. But I noticed that I really don't want to divide by 2, by 0. So the domain of my original problem would be that X cannot be equal to the number 2. But that automatically tells me that the range of my inverse would be that Y cannot also be 2. That's sort of telling. Another little thing that we talked about in class is that when you look at problems where the numerator and the denominator are of the same power, all we have to do is look at these leading coefficients, which is 4x and 1x. That means somehow what's going to happen is that there is a horizontal asymptote at y equals 4. But in this case, we happen to know, and it's just practicing this kind of problem. Sometimes you can cross horizontal asymptotes, but in this case, you won't be able to cross that horizontal asymptote. So we should be able to predict what is happening, because remember, your original domain becomes your new range. Your original range becomes your new domain because X and Y switch. So here we go. We're going to start by swapping X and Y. Next thing we're going to do is we'd really like to get Y by itself. So I like to cross multiply. And that would give me 4y minus 7 equals xy minus 2x. Because remember, x times y and x times 2. Now, that achieved a very good thing because I no longer have a fraction, but unfortunately, if I want to get y by itself, I now have y on both sides. So we're going to go ahead and move some things around. I'm going to move this xy to this side and this 7 to that side. And by doing that, now everything that involves a y is on the left side. Everything that is not with a y is on the right side, because now I can factor the y out. And of course, then the only thing left to do is to divide both sides, and y would be by itself. So that leaves me with a final answer of -2x plus 7 over 4 minus x. Now, that is actually working pretty well, because you would notice right here, if I tried to let x be 4, then I would have a division by 0. And that's something that we cannot allow to happen, right? So I think that should be sufficient for this portion of the review, and I will see you back in class. Thanks for joining me for a little bit. Hopefully that helps. Let me know in class if you have questions. Bye-bye.